Ooh. I don't know, our website looks pretty cool, actually. I might just give the presentation this way. Just watching our own stuff. I'm guessing you guys have probably all been here. Has anyone not been to our website before? Sounds like, yeah, because chances are you all registered. Did anyone have any trouble registering? Or did it just go great? You all registered fine? That is so good. We've been working on our system for several years now, and it's gone from nightmarish to almost user-friendly, so we're really getting somewhere. So you've all been to the user dashboard and done all that kind of fun stuff? All right, cool. Well, about 30 seconds out. Jim, was anyone else coming from our lab? Or I mean, you could probably just, that's cool. All right, well, awesome. Brandon, you good? All right, we are good to go. Awesome, well, welcome everyone. My name is Ray. I manage the I2P lab, Idea to Product, I2P. And we're here to give you a crash course in 3D printing. We also have some scanning classes. We only, I think, have 2 this semester, but if you're interested in getting a little bit deeper dive into scanning, I'll tell you just about, about a minute worth of what the scanning technology is we have in our lab, but you can also attend one of those if you'd like. But I'm going to jump right into it because time is always of the essence. If you want to check out our our training at any time, it's right here under resources. And I just made updates to it like 20 minutes ago, so you can come here and run yourself through the training. If there's anything I just skimmed over too fast and you're like, oh, what was it that Ray said? Which totally reminds me, I forgot to print out the quizzes. So if you want to do that, that would be awesome. This is new, and it's not to make it harder, it's actually to make it better for you. We're going to give out some quizzes just to make sure that you get some of like the stuff that we really want to make sure that you get out of this training. And that should be, you can ask us about it. Basically how this training is going to go is we're going to run you through what is 3D printing. Chances are you've got some idea about this already. And then what the printers are that we have in our lab. You may also have some ideas about that, but we might have some that you didn't know we had, which is why we mention it. Materials, because 3D printing is big. The materials is a big issue. Just as an example, the castle we're passing around here, you can print in a number of materials, but some materials for something that big will be a lot better than others. And I will get into the why it is that way, what kind of materials may be better for certain projects than others. Some of the software we use, a bit about just the ins and outs of using our lab, and then we will actually go and check it out. So hopefully I'll be done here in the next 30 minutes or so, and then we'll zip over to the lab and you can actually see it in person. And then we'll get you marked off as trained, and you will be ready to go. Let me get this out of the way here. Okay. So cool. What is the Idea to Product Lab? You may be asking. The Idea to Product Lab is a lot like a makerspace / hackerspace. You may have heard of those. It's basically we get our hands on equipment that you want to be able to use for your projects, for your class projects, for all kinds of stuff, and just put it in your hands, and you basically get to kind of learn by doing, but also while having a staff of myself, Will over here, Jim, who just ran to print out some quizzes, and David, who's been with us just for a semester now. We are actually, just as an interesting bit of history, we're based out of similar labs that were originally started in South Africa at some universities there. So anyways, I got to go visit them about a year ago, and it was really, really cool. So let me see. Hopefully our sound is good and not too good, because I don't want to blow you away here. But sound is always a question. There is sound coming out. I can hear it. It's just not that loud. Oh, I'm going to show it there. Well, oh, there it is. Okay, cool. Let me just restart this. This is just a quick 2-minute video from a university in Scotland, which is really cool. It just gives a quick overview of some of the key points of 3D printing. Is that, can you hear that okay? Or kind of not really? It's only coming out of one of the speakers. Okay, well, if you can't really hear it, I may just run you through it myself. Yet again, this is one of those things you can go to our website after the time, or after this training and watch the video if you'd like. Basically, it just kind of runs you through what 3D printing is, what 3D printing files look like. It gave a little bit of a history on the history of 3D printing. What it looks like to slice a print, which I will also run you through, so you won't miss anything there. And then what 3D printing generally looks like, just like it shows here. You may have seen this kind of printing before. There are several different methods, and I think I have a slide on 2 of the more critical ones that we do. But this is just a simple extrusion 3D printing. I'll refer to it as FDM, or fused deposition modeling, which is a long term for spitting out plastic, kind of like a hot glue gun or any kind of extrusion process like that. But it basically extrudes material into a specific shape, and one layer at a time, it starts to build up the model. And that's the main type of 3D printing we have in our lab, and the one that is the most accessible, cheapest, and you get some parts that you can actually use for things. And this is just showing it being built up. And it also highlights one of the other things that's inherent to 3D printing, any kind of 3D printing, but especially this type, is that you're printing up layer by layer. And these little bits here are support material. So if you're printing a bridge and you print the 2 towers of the bridge, layers at a time, then you get up to this layer where it's time to kind of connect across the towers. You'll be doing that in midair. If you can imagine, you've got 2 towers, then nothing underneath them, you'll be spitting out plastic into midair. And some printers will actually be able to, they call it bridging, bridge that gap moderately well. But if it's something big like this, especially this is a whole base of a race car, you'll need to generate some support material underneath it. And I'll go ahead and lead you through how to do that. But that's something to consider if you're designing your part with 3D printing in mind, then you can kind of minimize those overhangs so that printing is easier. A lot of people will have more, like a 45-degree angle is pretty easy to build up. So if you can build your bridge with a 45-degree kind of tower that leads up to it, that's a lot easier to print. If your part isn't designed for 3D printing, like Formula One race cars, then you just kind of do the best you can. Although you can sometimes find better orientations for printing things. Like for example, they could have flipped this car up and printed it more vertically and needed a little less support, but then again, it might not have had the right detail exactly the way they wanted it, so it just depends. Okay, so we've got some, are those the quizzes you just passed out? Sweet. You guys can take it too if you want. Not all of the answers are extremely straightforward, and I did that on purpose because I want you to go ahead and think about it a little bit, and and we're not grading super harshly on them either. But as I run through some of the things, hopefully you'll just see it and go, oh, that's what you're talking about. If you have questions, also feel free to ask questions. We're not so tight on time that you can't ask, and we can answer questions for you. So okay, here we get into some of the fun meat of 3D printing. There's 2 different kinds. I mentioned fused deposition modeling, or FDM. That's actually a trade name. People call this kind of 3D printing all kinds of things. RepRap 3D printing, which we talk about sometimes because these are RepRap printers. That was actually, the first RepRap printer was designed at a university in England, Bath, England. And they're basically self-replicating machines. The idea was you make them open source, and then one person can build one and help build the parts for their friends to build other RepRaps, and then those would build other RepRaps. And it was kind of the idea for like a democratization of manufacturing. And it's worked out pretty well for us. Those are the machines that we're able to use and make lots of prototypes and useful things and fun things. But basically, it just uses thermoplastics. It heats them up, they become soft, and it spits them out in the pattern that you need. And a few layers later, you've got your part. Generally, lower cost because the materials are really cheap. You know, Legos are made out of thermoplastics. There's thermoplastics everywhere. You know, this power strip has a thermoplastic molded casing on it. So it's just a very low cost way to do this 3D printing. But it is relatively low resolution as compared to some other methods. The machines we use have a nozzle of about 0.5 millimeters. So any feature that you have in your model that's smaller than 0.5 millimeters probably won't come out because it's just, you know, not high resolution enough for that. And then you've got SLA, or stereolithography printing, and that uses a liquid resin. It's a photocurable resin, which is just it's a special, you know, it's a goopy kind of syrupy resin that reacts to light. And when you shine a high intensity light of a specific wavelength, it cures it into a solid plastic. So that means that your resolution is only dependent mainly on the resolution of the projector you have in there. So these use usually like, you know, high-end Texas Instrument DLP projectors or lasers to get the detail that they want. So this one, well, the Ember and some of the others will get you resolutions more, you know, an order of magnitude finer, more like a 0.05 millimeter instead of a 0.5 millimeter. And I'll talk a little bit more about those specific printers, our printers, right now. So these are all FDM printers. We like Lulzbots because they're made literally down the street in Loveland off 287. If you get to go there at any time, I recommend it because it's a fun tour to have. And I used to work there, and a lot of the stuff that I printed is still there on their desk, so I want to promote myself. Ha! Just kidding. No, it's actually really cool because they also have about 150 printers there running round the clock, printing parts for their printers. So they took that RepRap model and basically scaled it up to a crazy level to where they are running a business having printers printing printers. So it's really, really cool. But that also means that they're a pretty rugged design, and we know that we use them pretty hard, but they use them really hard. So anyways, you got the Taz, just the larger format printer, and then the Mini, clearly a little smaller. One of the easiest ones to get started with is the Mini. Basically, you load in your model, you slice it, and you hit print and go. The Taz is nice because it does not have to be connected to a computer. So it has an SD card reader right here on the side, which you'll get to see in the lab. And so you slice your models, you load the G-code file that's produced onto an SD card, and you load them in there and you go. The Taz 6 has a build volume of about 275 by 275 by 250 millimeters. And it's mostly a very, very open source realm, so they use a lot of SI units. If you like inches, just switch. No, I'm just kidding. Actually, I forgot to ask, how many of you guys are in mechanical engineering? That is quite a few. Okay, is anyone not? Is anyone from somewhere? Where are you from?
Where am I from?
I mean, sorry, what department are you in?
Oh, I'm in neuroscience.
I mean, you can tell me where you're from if you want. Neuroscience, that's really cool. That's super cool. Do you already have projects in mind you want to do, or just exploring? That's awesome. That's great. Yeah, okay, so a lot of us are MEs, so depends whether you've been trained in the English system or not. Most of the 3D printing stuff that we use is in millimeters and kilograms, and that's the way we like it. But anyways, so a little conversions to do there. The mini build volume is a little less, more like 150 millimeter cube, so about 6 inches or so. You can actually do quite a bit with that. Let's see here. And then the Hi-Rel is actually one that is on its way. We think it should be in the mail coming to us, and it's just it's supposed to be a higher reliability, larger printer that you can put modular heads on, print 3 materials at a time, do laser cutting and all kinds of fun stuff. So we can't wait to get our hands on it. When it comes in, that should be available for your use as well. And then the RepRap printers are all included in your usage fee. You can come and print as much as you want. You just need to grab your own material. Whereas the SLA printers and our liquid extrusion printer here are a little bit more. We have special pricing for them. It's a couple bucks per hour because the maintenance costs and such is a little bit more. So the Ember is also an open source printer, which is really cool. And it prints down to 10 micron layer thickness, so you can get some really, really neat detail. Did you bring any of those parts, or mainly the? Oh, did they pass this one around already? So yeah, this is an SLA version of this, just scaled way down so you can see some of the detail that you can get there. But yeah, so 10 micron resolution, you can print really, really tiny things. It doesn't have a huge build volume because of that. You can print parts about this big, rectangular. But if they have to be really fine, then you can get the detail there. The Objet is really cool because it has an advanced support material, and it basically encases your whole print in support material. So if you have those overhangs and complex geometries, you can get those really simply, and then you just pressure wash your part to get all that support material off. It's kind of like a soft, easily removable polymer. The EnvisionTech is almost the same as the Ember, a little bit less on the resolution. They're more in like the 25 to 40 micron range, but they have tons and tons of super cool industrial materials that you can use. And so if you ever need to run some parts, higher resolution parts and things like that, just ask us and we can help you get started with that. Okay, so you might be more interested in FDM materials to get started. Interesting formatting there. That hopefully gets the info across, and I think that is one of the questions on your sheet. We made it big and we put it on the quiz because a lot of people ask us. In the industry, 1.75 filament is usually more popular, but all the printers that we have use 3 millimeters, and it should be about the same cost. But anyways, we just wanted you to know so you don't show up with 1.75 and go, hey, wait a second, which printer do I use? Of the materials, we really love PETG the best. It's a little bit pricier. Well, it can be a bit pricier. Now it's almost the same as the others. What's that?
22 bucks per kilogram.
Oh, well, okay. So that's pretty affordable. That's super affordable. Yeah, there's a. Do you know what company that is, or where is that? eSun. Okay. eSun is not my favorite. It's cheap. It's admittedly my least favorite printer brand. But anyways, but generally the material is cheap and will run most of the time. But yeah, and you can get PETG. Of their materials, the PETG is one of the better ones. So yeah, that's a good way to go. It's a strong material. It's similar to what your Nalgene water bottle is made out of. So it's, I can't say it's food safe because nothing 3D printed is actually food safe. It's got, it is, yes. It will be FDA certified, but once you 3D print with it, you've got about, a billion different spots in between your layers where bacteria can and will grow. And it's just, it's one of those things where you could probably print something and use it once or twice, but it would be a little messy to use it more than that. Yeah, and then it also has a lower warpage. So what I mentioned about the castle, I think this castle was printed with PETG. And the details came out nicely, and it didn't, warp up too much while it was printing. ABS is notorious for having warpage with larger parts like that. And that print took about, what was it? Was it over 48 hours? 90? Yeah, just because of the detail we wanted and the size it took, about 90 hours print time. So an ABS print probably wouldn't survive that long because eventually it starts to warp up on the bottom and it pulls up off the bed. So ABS is great for Legos and small things like that. Actually, Legos are made out of ABS, and we've printed our own. But for larger parts, ABS is not quite as good as PETG. And then PLA is super easy to print with and used to be way cheaper than the others, but now it's kind of relatively similar. So, and it is biocompostable, so if that's a thing for you, you're going to use something and then you want to be able to throw it out and not feel bad about it, that is it's a nice thing. It's, it's made from corn starch, and so it's nice and green. You can get your filament at Ramtech, Lulzbot. If you go visit them, they've got a bunch of stuff there. IT Works down in Loveland, although I'm not sure how much longer they'll be selling filament. Amazon, there's another company out in California called Matter Hackers, which I really like their stuff. You can get good stuff there. If you want, do you have any questions? Did I go too fast about materials? If you do, fire up a hand and I can be happy to answer those. A couple more exotic materials, some fun materials and some really useful ones. T-glaze is almost the same as PETG. It's actually PETT. So if you're a chemist, that means something. If you're not, it doesn't. Because it's almost the same, both polyethylene tetraphthalate based polymers. The nice thing about T-glaze is all their colors are very clear. So if you need something that's more or less optically clear, then that would be the material for you. Note though, no matter how clear the material is, once you build it out of layers, it's not transparent. You can't print glass or a window or something like that. You can print frosted glass because it's got all those little, imperfections and things that make it opaque. So you could use it for, like a diffuser for a lamp or something like that, but you couldn't use it for a viewport or a window. Then laywood and some of these materials, the laywood and the metal-infused PLA, they are basically PLA with those materials added into them, and they extrude super easily like PLA and have some properties that could be useful. You can stain the wood. It's got actual, sawdust in it. So you can stain it like wood. It looks like wood. The metal ones, you can polish them. You can, you can rust them. We have some rusted iron PLA parts. So mainly for art projects, things like that. The iron one is magnetic. Unfortunately, the copper one is not conductive because the copper bits are floating in a polymer matrix. So they're basically, floating in a dielectric. So there's no way to, get current through them. Although supposedly you can get maybe a little bit, but super high resistance. And then NinjaFlex is super useful because it's flexible. So you can print flexible parts, watch bands and phone cases and that sort of thing. Airless tires, we've seen all kinds of fun stuff printed with NinjaFlex. But it does require a special extruder. So currently R2D2 in the lab is set up with that kind of extruder just for that material. And then polycarbonate alloy is or PC ABS. You can get pure polycarbonate as well. It's just a little bit stronger, more impact resistant plastic, but it can be a little more difficult to print with because it contracts even more than ABS does. And then carbon fiber filament is really cool and a little bit stronger than regular filaments, but it is abrasive to the nozzles. So I just put print on to be announced because we have special nozzles ordered to be able to take that kind of abrasiveness and not wear out.
Are they CFF printers or are they chopped carbon fiber.
Those are all chopped carbon fiber. Yeah, there's only one company that makes a continuous fiber printer right now, and we don't have it. But we've talked many times about getting one because it's really cool. Yeah, it would be really cool. Yeah, you can get just chopped carbon fiber in like nylon. We printed with some of the Nylon X, right, from Matter Hackers, and it was pretty cool. But you print with a whole spool of it through a brass nozzle, and you know, carbon hardness versus brass hardness, the brass loses and your nozzle slowly gets really, really big. It's literally just wearing it out into a larger nozzle size. So that's why we need special hardened nozzles to print it continuously. Okay, so some fun about scanning. I'm just gonna tell you about the scanners, and then if you want to use them, you can set up some time with us. We have a Sense scanner, which is just an optical scanner, which is really nice because you can scan. You can scan large things. You can scan people, and you're not shining lasers in their face. It's kind of fun. You know, I saw a guy, he had done it. He just stood like this and let someone scan him, and then printed a version of himself about this big and put business cards in his hands. And I was like, that was the cheesiest but actually really cool thing that I've ever seen. But it was really neat. So anyways, you can do stuff like that. It goes down to about 1mm resolution. You know, so if you need to scan a tooth, maybe not. The Handy Scan is a laser scanner, and requires a little bit more as far as positioning. So we have a platform with little positioning dots all over it so that it can track those dots in 3D space and scan your object. And that when we have scanned teeth with, you know, actually fossilized teeth and diamond rings and all kinds of crazy things. So there is some possibility if you need to, you know, get a 3D scan or a replica of something that's kind of complex that you can't design otherwise, scanning it is the way to go. Oh, here's an example of that. We had this team of sculptors, and they made this really nice clay sculpture. It was about this big. And the goal was they were going to take it up to Breckenridge for the annual snow sculpting competition and sculpt it 8 feet tall. And they said, but if we take this up there, it's cold, it gets brittle, we pass it around, and it's just definitely going to break, and then we'll be in trouble. So they said, can you scan it and print us another one? So we did. We scanned it, and then we 3D printed it in a couple pieces and glued it together and had a nice solid scan they could throw up on top of the snow sculpture as they were making it. And I think they took like second place. They were super excited about it. So that's just an example of where you can do some scanning and some printing to get your job done. Okay. So scanning and 3D printing both use STL files. Printing more. Scanning actually uses point clouds that you convert to STL files. But an STL file is nice. You can get it from any CAD program you use. I haven't found one that doesn't produce them. But they could be out there if they're really old. And is that right? Or did you find one that Autodesk? Really? Those crooks. Really? That's crazy. Okay, well, so if you
Yeah, Fusion 360 is about
okay, that may make sense. Okay, so most CAD programs, that remains to be seen. They may just make it really hard to find. But an STL file is effectively a set of triangles. It's a whole bunch of triangles that make up the face of a solid object, although it doesn't have to be solid. I'm going to talk about that in a second. But yeah, they make up a 3D shape. So it doesn't, you know, STL files have no circles. They have no curves. They are all just a bunch of triangles that make up a big polyhedron, basically. And then, yes, I did also note, so because of that, they're not the same as a regular CAD file. They don't have perfect circles and curves and things like that. So if you get an STL file and you want to edit it in SolidWorks, you have to go through some conversion. And we do have software that makes that possible, but it's not always perfect. It's kind of like if you're familiar with doing vector art, like in Adobe Illustrator. and you can convert that to a JPEG file and use it in Photoshop. But going back the other way is a little bit harder. So it's kind of the same as that. You can also download existing models on websites like Thingiverse. There's tons of them. You can go to, if you've got money and you need a super premium model, you can go to Turbo Squid and other places like that, websites where professional designers will upload super complex models, some of which sometimes have too much detail for 3D printing, but they're just really, really cool. But the caveat with that is that STL files, especially from Thingiverse, are not always perfect. And I listed some of the ways they're not perfect. They can have degenerate faces. And anyways, there's lots of issues where, if your triangles don't overlap perfectly, or there's duplicates that overlap completely, or there's missing faces altogether and you've just got a hole, and then your model doesn't actually, it's not solid, it wouldn't hold water, then you can get into a little bit of trouble. So we've got NetFab for doing automatic repairs, and any of our staff can help you do that. If you go to slice your model and it doesn't look quite right, talk to one of our staff and we'll help you NetFab through it and hopefully fix the issues. Otherwise, you can go to a more in-depth repair in Blender, which is an adventure in itself. And then as far as software to use, we have this, you can look at this infograph on our guides page, but there's a lot of different softwares out there. And this guide is also, even just a couple years, it's already getting dated because there's lots of new software tools to help you design better and faster. But the main difference is whether you're doing, a lot of you are mechanical engineers. If you're designing machine parts, you'll probably do a more parametric CAD kind of program, SolidWorks, Autodesk, any of those, Onshape, which is a free one that I like. And then you've got more organic modeling softwares like sculpting. They're basically digital sculpting tools, including Blender, and I guess SpaceClaim kind of falls somewhere in between because you can do both, but Fusion 360, some of those more organic ones are on this side. If you need help or you want to test out software, we've got a ton of it in the lab. I also didn't mention, materials. If you want to test materials before you buy, try before you buy. We have a lot of material, and we'd be happy to let you run a small print just so you can kind of get an idea of if a certain material is going to work for you. So come talk to us if you're wondering about that. And then I think you've got another obvious answer on your quiz here. Printing in Cura. There's a couple things you want to do. The first one is very obvious. Load your model. So get your STL file, make sure it's all good to go. Throw it in here. It'll show up on the build plate, which is the same size as the printer that you're going to use. And then you want to go to quick print settings. So quick print settings, there's an advanced settings, which you can kind of see here, which shows you all the different options. Oh, I forgot this isn't our computer, so I don't have Cura to show you. It'll have all the different options like layer height, print speeds, infill percentage, things like that. Stuff that you may want to change. But before you mess with any of that stuff, keep in mind that when Cura opens, it just loads whatever settings the last person was using. And those might not be the right settings for you. And they're probably a different material altogether. So always go back to quick print settings. That will just ask you what material you're using. Do you need it to be fine or fast? The higher resolution prints, of course, take longer. And get you some of those simple settings. It'll ask you if you want supports or brim. We talked about supports. This little octopus here is completely flat on the bottom and he's got no overhangs, so wouldn't need any supports at all. Brim is, I mentioned that because if you're printing with ABS, or you're doing just a long print or a big flat print with basically any material, if it's a big print on the TAS, probably throw a brim on there. It just adds about a centimeter of material around the edge on the first layer just to make sure that, that it's going to stick down really nicely for the whole print. And so that's a useful tool to use. And then, oh yeah, orient and scale if needed. That's the other thing about STLs is they don't have any units. So if you designed them in millimeters, they'll show up, it'll show up at the right size. If you designed it in inches, Cura thinks it's millimeters anyway, so it'll show up about this big. And you have to scale it up by 25.4, 25.4 times size. And then you can also rotate it if it comes in and you have a nice flat side you wanted it to print on, but it's oriented this way. You just rotate it down, and you're good to go. And those are the basics. It's not too hard to do at least a basic print. You load your model in, get your material set, supports if you need it, and then it'll give you a little estimate, time estimate, and how much material it's going to use. And then you just hit Control and print. Basically like printing a document. And then the most critical thing with the LULS bots, the TAS6 and the Mini, is the probing. So they have these aluminum washers on the four corners of the bed, and the nozzle itself is actually going to probe those four corners. Now the reason that's tricky, can anyone guess why that's kind of a tricky process? This is making an electrical connection. Can you guess why that's a little scary? Anyone? Hopefully you're not asleep by now.
It's an insulator and
Exactly.
you have any use that other nozzle and crashes right through it.
Exactly. That's exactly what it is. Yeah, so this nozzle, though it's metal, spits out plastic, which is an insulator. So if there's any plastic left on it and they get dirty over time, it won't make a good connection here. Now, it goes through a wiping process beforehand, and that's usually pretty reliable, but not always. And so it's up to the user. This is kind of the only thing you really need to watch, is that it comes down and touches the washer very gently, and then comes up and touches off on the other washers. It touches each one twice. It shouldn't press those washers down at all. If you see the washers deflect, or you hear nasty grinding noises, then that's a problem. And then you can just kind of flip, just turn the printer off, turn it back on, and hit print again. We've got little wipers around to wipe those nozzles off if you see any plastic left on it. I called this the Goldilocks first layer because it's really hard. Sometimes your layer is way too low and it's just completely squished and you can't see the sides of it at all. Sometimes it spits out a layer, your first layer, and it's just this round bead. And if it's completely round, that means it hasn't really attached to the base at all. So this is really hard to see, and I apologize for that. But basically, you want to see a nice flat top and round sides. And that will be your perfect layer. And either of these will probably work out okay. But generally, that's sort of what you want to see. Rounded sides, flat top. And just pull one of us over and we can kind of help you take another look at it. Okay, we're getting close. Are there any questions on the quiz that you had questions about, or things that I said that were very unclear? Because Ray does that sometimes. Yes?
What's the time limit window to show up?
The time limit window. I may mention that, but I'll just say it now. We ask that you come in within 15 minutes of your print reservation, and so that we know that you didn't forget. If you made a reservation and then you don't show up for 15 or 30 minutes, then we'll go ahead and offer that printer to other users who may need it but couldn't make a reservation. Because that happens. We all forget that we made it and then don't show up. So cool. You are getting very close to printing. You're trained almost. You'll pay a lab fee, which this semester we're really happy to announce is $15 for all students. It was much more than that in the past, but we were able to convince several organizations at CSU to finally fund us, which we're thrilled, and now it's a lot cheaper for you guys to use the lab. That being said, probably more people will use it, so if you have projects, get them in early. We have just simple instructions how to use the printer. You've been to the user dashboard before. You really just go in, you hit add reservation. You may have to take a look and see what's available first, because if you try to overlap on the same printer with an existing reservation, it'll say, you can't have that spot. So you'll have to take a quick look at it before you go to reserve. And just a little pro tip, add a little extra time. Sometimes if you're really smart or prudent, you don't have to be smart, you just have to plan ahead. If you're prudent and you sliced the model in Cura beforehand, and it gave you a time estimate, if it's a mini, that time estimate will be close. If it's a TAS, it's probably going to be a bit more. So just add a little extra time, 30 minutes to an hour extra, or if it's a long print, if it's a 24-hour print, I don't know, give yourself 30 hours or so just in case. Hopefully you won't have to do too many of those big prints. And then show up, oh there you go, within 15 minutes of your reservation. And then this is just kind of a word to the wise. This is what our reservation calendar looks like in the last 4 or 5 weeks of the semester. So start your projects early and get some use. Even if you're like, well, I don't know what I'm going to print yet. Well, print something fun. If you're going to buy a pass anyways, you have the whole semester. So come do some fun prints. Burn a little plastic. Burn some of ours. We'll help you at least do some printing and get your feet wet. Because once it comes to this time, it's a little hard to get print time in. We're trying to keep our printers up and maintained as much as possible, but even still, the demand is great, and the printers are few. So let's see here. Yes, I also mentioned after-hours access may be granted to experienced users. Please have at least 15 to 20 prints under your belt when you go to apply for it, just so that we know that you kind of know your way around. We've got fancy card readers on the outside, so you can come in at midnight and 3D print, because that's what everyone should be doing at midnight. But anyways, that'll be available. And safety first. We mentioned it last because save best for last. So be cautious of the nozzle. It's hot. We figured that would be, it's self-explanatory, but we all touch the nozzles anyway just because we're just daring and stupid. It's hot. They're about 230 to 300 degrees Celsius, so that's hot enough to burn you. But hopefully it's not too bad. If it is, we've got equipment for that. Pinching hazards. The beds move, so don't stick your finger between the bed and its races. There's acetone and alcohol in the fume hood, and that's not for drinking. Just be cautious. We use it for finishing prints and cleaning prints and things like that. So, of course, just use simple chemical. If you ever have to use it, grab a pair of safety glasses. We try to have them available. And we also have the fume hood, so keep you extra safe that way. Knives and scrapers are sharp. I think that's one on there. Sharp things are sharp. Hot things are hot. Try to keep them away from you. Don't ever try. There's knives that help pry the parts up after they're done. Never try to pry a part with a knife at yourself. It seems intuitive, but in the moment, we all do it. I don't know why it is. So we're just mentioning it now. Just have that caution. Always point at a knife or a scraper away from you. I got some funny, bloody stories about that. And then if anything goes wrong, just turn the printer off, and it'll stop right away. And then when in doubt, we're here for you, so just ask one of us. Okay, so what's next? We're going to take you over to the lab. You can grab your lab. Actually, well, incidentally, you can't purchase your lab pass yet because we also are implementing a system where you can pay your lab fee on your student account. And that'll be cheaper for you, cheaper for us. That was what helped us get the cost down. But it's not up yet. So in the meantime, if you want to print, we'll go ahead and mark you as paid, and we'll just let you know when that's available, and you can put it on your student account. And then, start printing right away. Practice and patience make better. But anyways, perfect-ish. Cool. Thank you. We'll go ahead and you can follow any of these guys over to the lab so you can take a look at it. And I'll be right behind you.